Welcome. This new module, we will learn about visualization, like how to produce high quality and compelling and engaging figures for your proposal, report, whichever paper, whichever document, thesis, dissertation, whichever document you are working on. Yeah. Okay, so we will start by saying like what is a publication quality figure, and then in the next video I will talk about like conceptual figures and visual abstracts. Yeah. Okay, in the next video. Okay, so let's just get started here, and so by the end of this video, you should be able to describe like why, oops, what, and how, the how of the publication quality figure. Like, why do I need a publication quality figure? What is a publication quality figure, and how to produce a publication quality figure or to develop a publication quality figure? Then you should identify like the available tool posts like commercial and free software for editing like raster and vector figures. So there are two types of figure which we will learn also about them. One is called raster and one is called vector. So we will learn what's the difference between these two. By the end of this video, you should be able to identify, oh, this is a raster figure, this is a vector figure. And you should be able, like if I want to edit any of these figures, you should be able to know what tools are out there. Yeah? But more importantly, you should be able to assess the publication quality, like the quality of your figure, yeah, like the quality of your figures, and that's in this, like in the research method course, uh, you might not have figures, but in other courses, like in the project course or a thesis or whatever, you will have figure, yeah, and so you need to assess, like in order not to lose some points, you need to assess, is this a publication quality figure, and if it's not, how could I fix it? And then how could you fix it? You go back to this video, or you just watch this video. So if you watch this video, you would know, and that will make things easy for you. Because, okay, so let's get started. Okay, so why do we need a publication? Why do we need a figure? Not just a publication quality figure. Like, why do we need figures? Because after, like, you see how much effort you're putting into this. So, for example, like if you are doing like the research method and the project course, like see, this semester you're spending planning and learning about your topic, and then if you're doing the project next or whatever, you take this course. If you have to take it, some students don't, some students do. uh, uh, if you have to take it, this course, then you will spend another semester working on this, like developing like implementing your proposal. If you are doing thesis, you could spend more than one semester. You could spend a year or even more. If you are doing a dissertation, even more. Yeah. So after all months or even years of working, if you are doing dissertation, or whatever research you are doing, because remember, research does not only related to thesis, dissertation, research. I told you many engineering companies, they do research. Yeah, it's called like R&D. Yeah. Okay. So after months of working, you are ready to share your findings with the world. Yeah. And if you want to share your finding with the world, like as they say, like an image is worth like 1,000 words. So figures could be like very powerful tools. One of the most powerful tools for sharing your finding with the world. So that's why uh, you need figures. But why these figures need to be of high quality? Well, these figures, So here, that's the first thing. Oops. These figures need to be with high quality because the quality of your figures will indicate or reflect the quality of your work. So if you are like meticulous person who's paying attention to every little details, who is rigorous about everything you're doing, who like to do whatever you are doing at a good quality, uh, so your work would be a good quality, and accordingly, figures, which is part of your work, would be also of a good quality. So if you are doing high quality figures, that somehow reflect or indicates that you are doing a high quality work, yeah, and you are rigorous and meticulous about what you are doing, yeah. So that's another reason why you need like a publication quality figure. Okay. Uh, what are other reasons, like why do we also need publication quality figure, or a figure in general, yeah, like uh, because a figure, it tells the reader a concise story. So it will help the reader, for example, like if this figure is about your method, it will help the reader to understand your method. And I will show you an example, I think, next video. Yeah. If it is about the results, it will help the reader to understand your results. If it is a visual abstract about like the research that you're doing, it will introduce the reader to the research that you're doing. It will help the reader to appreciate what you're doing. It will help the reader to see the significance of what you are doing, depending on how you design it. Yeah. So each figure is a story that you are telling. So you need like to make like a good story, write a good story. Yeah. And that's why uh, like if you're like just when you see like a good movie and a bad movie, yeah, it's a good story or a bad story, like good visual or a bad visual. That's basically the same thing you're doing here. And the better, again, the quality of your figure, the better will be this work, yeah. and and that's why, like for example, some students, they told me, oh, I didn't get a good grade here. And then what I will do, I can show them like the student who got an A. What is the student? What are the figure quality and the student, and the quality of work for a student who get an A versus the quality of work for a student who get a B or a C. Yeah, and then in if you go also to your course website, you will see some work of previous students. So the work of the previous students, the proposal and the reports, I put it there on the website. I share it from their GitHub repository. And I mean, of course, I don't put the grade there. Yeah, like I didn't say, oh, this got an A and this got a B or this whatever, but you will see it. Yeah, like you just open this one and you will open this one and you will see the difference. You will see the contrast. Yeah, and and uh, and you can also come and chat with me, and I can provide you with more guidance on this. Yeah, but if you just watch this video, follow the instruction here, that's exactly what you need. Yeah, this video has like all the information that you need. Yeah. So you now another thing, like another why publication quality figure, is just the same reasons that I was discussing, is that like a poor quality figure can increase the annoyance level of the reviewer. That's just remember like the papers that I asked you to review about why is the blessing to be rejected. In this papers they talked about something called the annoyance meter, like how like you can do one thing to annoy the reviewers and another thing to annoy the reviewers, and this annoyance meter is building up until at a point the reviewer will say, okay, I mean, I will reject this paper. Yeah. So don't add like what you are trying, your objective is to reduce the annoyance of the reviewer, not to increase it. Yeah. And if you have a poor quality figure, again, the reviewer will say, this figure shouldn't be published. Like this low quality figure, this, and I will show you an example. Like this type of work, we are not showing like a good example. Same for an instructor. Like the instructor, when we see like a poor quality work, he says this poor quality work should not get a good grade because we because grading need to be fair. I cannot grade somebody who watches this video, learn it from this video, did a high quality figures with someone who didn't do this. Yeah, have a high quality figure or someone who didn't do this. And our program also get reviewed. So if you get like if you give a good grade to a poor work, that will not show good in reviewing. Yeah. And so another thing is that like pay attention to like what's called like the annoyance meter. You don't want to annoy the reviewer or the grader or whoever, like whether this is like a research proposal, whether this is a bid, construction bid, whether this is like a software bid or whatever, whoever is taking this course, you don't want to annoy the reviewer or your grader. In that course, the reviewer would be like your supervisor or your course instructor who will be grading your report, yeah, or your presentation. Okay. Final thing, this is also related to publication quality figure and ethics. We talked about, I think we talked about this in ethics, but I will just like to bring it here, is that you can use this software for fraudulental figure manipulation. So you can use this graphical software or editing software, or even like the softwares that you use to produce the figure, like Python or MATLAB or Excel, to fraudulentally like manipulate your results, and that could lead to rejection. Like so, and it happened before. Yeah. Uh, Sometimes if I feel something is not, I don't feel good about it, I will just communicate my feeling to the editor, and the editor will might take this into consideration. Yeah. And the author is not going to know about it, by the way. Yeah, because the reviewer could communicate with the editor without the author knowing. Yeah. So that could be like it could lead to rejection or retraction. Like after it published, then people will discover this sooner or later. Then the paper will be retracted. And there are like different. By the way, fraudulental figure manipulation does not mean that maybe I will omit part of my results or I hide something. It could be even I change like the scale or like play with figure. Like I want to show like something is significant, for example. So I showed like in a red color versus everything around it in like a green or a blue color. And the reason that this red color is there is that because I'm playing with the scale to amplify this. Yeah. And that you think like you're smart by doing this, the reviewer will pick this up. They will tell you, like, yeah, I mean, it showed clearly on your figures that there is a difference between like this and that. But that's because you are just like it's like a scale issue. Like if you increase your scale, that I mean, both of them will have the same color, and that strong visual like evidence or like impression will not be there anymore. Yeah. So make sure also that's also part of the publication quality figure. Like don't try to cheat because it will be figured out. Yeah. Those reviewers are smart and whatever, and they will figure it out. Yeah. So that's I think that's all about like why you need like a publication quality figure to avoid your work getting like rejected, yeah, or like retracted, yeah. So I think that is uh, that's what you need to know about this. So uh, let's look at what is before we look at what is a publication quality figure, I can show you what is not a publication quality figure. So I want you to look at this figure and tell me, is this like a publication quality figure or not a publication quality figure? And so this is like a scatter plot. So this uh, scatter plot for non-carcinogenic risk of aluminum in Shiraz drinking water group, children, adolescents, and adults. That's all what this figure have. Yeah, and that's it. Yeah. And so I would assume like A is children, B is adolescent, C is adult. So I don't know what is A. So I don't know, like, because this figure does not tell me where is A, where is B, where is C. Yeah. So maybe this is A. Probably this is A. Is this B or C? I don't know. So you see, like, because you don't have this type of annotation. So I don't know, like, so okay, maybe this is A. That's the first one. But is this B or this is C? I don't know. Yeah. So now you leave the 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 whatever, like the reviewer or the reader to guess. So maybe I will guess, okay, maybe this is B and maybe this is C. Maybe, okay, that would be my guess, yeah. Now I will look here and I will like look at this, yeah. I mean, can you read anything from here? You might say, oh, this is a small figure. Can you read anything from here? Can you read these axes? Is this legible? Is this legible? Is this legible? No. Can you read anything from here? Is this legible? I cannot read anything from here. Yeah. So the figure is not legible. Now you look at these axes. Uh, all these figures are just showing the same thing. Yeah. I mean, but do they have like a consistent like scale? Like if I want to compare like BW, for example, BW here and BW here, you see their scale here. This goes from 0 to 20. This goes from 0 to 80, yeah, and this goes from 0 to whatever here. So they are not even at a comparable scale. So I don't know where these are. I cannot even compare like these three group if I just selected like one of them. Not to mention, I don't know what is this BW. I can barely read it, but I don't even know what is this. I can barely read this C, but I don't even know what is this. Yeah. So that's like, so that is another problem here. Now you look here. Look at this text. What is Y? Like, do you know what is Y? I don't even know what is Y. Did it say anywhere here what is this Y? Or anywhere in the figure? I don't know what is this Y. But regardless of what Y is, can you read anything from here? I cannot read anything from here. Yeah. Can you read like here maybe, but like you see, it's very like here's the text is a smear. I cannot read it. Here's the text is not smeared, but the slow font is very dense. I cannot read anything. Yeah. Maybe here I can read it, but the text is small. Yeah. But like I can read at least like negative point 5, negative 2.5, and 0. At least I can read this. Yeah. But see, the axes are not consistent. So you see, like, should I, like, if you were a grader, like if you are grading like the final uh, project or thesis or whatever, would you give a good grade to this student or no? What do you think? Yeah. Yeah, the answer is no. Yeah, because this figure has a lot of problems that needs to be fixed. Yeah. So this is not a publication quality figure. It's a lot of data, but it's not a publication quality figure. So first of all, it's illegible figure. I cannot read it. Yeah, small font, smear data. So here you have everything almost as a small font. You have like smear data here. So that's just like uh, so here like small font, smear data. That's an example of a smear data. What else? Missing font or standard axis, missing a non-standard axis label. So that's even one thing I forgot. Like, what is the label of this axis? Yeah. What is the label of this axis? Yeah. So the label axes are missing. I don't know what is here and what is the x-axis label. Yeah. What is the label of this axis? Yeah. What is the label of this axis? This axis. Yeah. So the axis labels are missing or non-standard. Poor resolution, like the font is like the figure itself is a poor resolution, like poor color contrast. Like you see here uh, even like the scale and the selection of the color, like because they don't have access, but the figure itself it has the poor resolution. Like you see here, this gray color is not very clear. So I don't know, is it because of the choice of color or because of the resolution? But like this gray color should have been black or something. But that could be because the figure has a poor resolution or poor choice of color. Yeah. Acronym not defined. Like all these acronym, like I don't know what's BW, I don't know what is EF. I can barely read them. I don't know what is R. I don't know what is like CMBW. I have no idea what these are. Like when I read this figure caption, I don't know what these are. Yeah. Acronyms not defined. Like inconsistent style, like inconsistent X ticks. So like you see here, the X ticks go from 0 to 50 and like here from 0, 10, 20. So it's inconsistent, yeah. And like even for the same variable, like so the same variable here, which is like BW and IR. So like you see here, it goes like 0, 20, 40, 60, 80. Here it goes from 0 to 10 to 20. So it is inconsistent X ticks. Like these ticks are inconsistent, yeah. What else? Inconsistent legend. The legend is not consistent because, like you see, here goes from negative zero point 0.5 to 0. Here goes from uh, 0 to zero point 0.2 to 2 and 0. So, like, see, this is inconsistent. So the legend also is inconsistent. I'm not like using this consistently. What else? Improper sizing. Layout space is not optimally used, and I will show you like about this because if you have a consistent ticks and labels for this one, you wouldn't even need this one. You can just put it here. You wouldn't need this one. You can just put it here. Or you can design this figure differently in order to make like the three groups. So let's say like how many things do I have here? I have like 1, 2, 3, 4, 5. I have 5 of them and I have three groups. So I can just like instead of designing this figure this way, I could just design it like 5, like 1, 2, 3, 4, 5, and here is my three groups. So that would be like, so if I put here the group like the here, that would be drinking water for like I put here like the children, I put here the adolescents, and I put here the adult, for example. And then that would be I put here the BW, I put here the like BW, like for example, like I'm just taking these fives, yeah. So here I will put like, for this one, I will put like BWEF. I put here BWIR, like that is here. I put here like CBW and so on. Like, so that would be this one. I put it here. I put this one here, and I put like this one here. Like I have 6 of them. Yeah. So that's another way of presenting this figure. Yeah. And that will make the comparison easy. So I can see like the BWEF for this group, for this group, for this group, same axis, same ticks here. Yeah. And that would be like same label. I will see like this same ticks here and same label. So that will make this comparison easy. I just look at it and then I can compare directly like the three group by just changing the figure layout. Yeah. And then I could, and I will show you how to use optimal space. I will show it to you in the next figure. Yeah. And then what is else? Unclear figure purpose. Like the purpose of this figure is unclear. Like when I look at this, the figure purpose is really unclear. I don't know what is the purpose of this figure. Yeah. So it is like an unclear figure purpose. Like by I don't like this scatter plot. Did you understand anything? What is this scatter plot is showing you or trying to show you? No, it's unclear figure purpose. Yeah. So that's why this is not a publication quality figure. So a figure like this will not get a good grade. Yeah. So let's move forward. Okay. So let's move forward here. So what is the problem of this figure? Yeah. So the problem, so here, this is probably what something similar to what I suggested. Like you make this like, so this is 4 by 4 like subplots. Yeah, this is a 4 by 4 subplots. Like what's the problem of this one? So the problem of this one is that it's like too much data. Like I have, see, this goes from 0 to 1 or whatever. Yeah. And the data is a smear because like the other one start here, so the data is a smear. Then I have this like this goes, sorry, from 1 to 0, and then from 1 to 0, from 1 to 0, from 1 to, and then I repeat the same data here, I repeat the same data here, I repeat the same data here. And you see this goes from 0 to 1, and I repeat the same data here, and I repeat the same data here, and I repeat the same data here. So the problem is like too much data and smear data, yeah? So the data is smeared and it's too much. So how can I make this data not smeared, like not, see here, the data here is smeared, the data here is smeared. How could I make this? Well, I can increase the distance. So I can increase this distance. 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 I can increase this called like white space. So I can increase my white space, yeah? So if I increase my white space, that will make the data not smeared. But that will still be too much data because this is redundant. Like, what, do I need this here, 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 here? It's redundant, yeah? Similarly, do I need this here, 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 here? It's redundant information, okay? So now what I did here, I just increased the white space. So that is, I solved the problem. The data are no longer smeared. Now I know that this goes from 1 to 0, and this goes from 0 to 1. Now this is clear, yeah? But it's not optimal use of my space. Why is not optimal use of my space? Because it's a redundant data like this, same as this, same as this, same as this. And here like this guy, same as this guy, same as this guy, same as this guy. So I have this extra white space that is not needed. Like, so one solution for this, if I remove this guy, if I remove this guy, if I remove this guy, and I just use a common x-axis ticks, yeah? Similarly, I remove this guy, I remove this guy, I remove this guy, and I use a common x-axis ticks. Similarly here, this is my y-axis ticks. I can remove this guy, I can remove this guy, I can remove this guy, and then I have a common y-axis ticks. Same here. Remove this, remove this, remove this, and I have this as a common. Now, if I remove this now, I can reduce my space. Yeah. Now here I can reduce my space. Then I will have an optimal use of my space, and this box here, instead of being that small, could be like that big. So now let me show you. Like, see, if I optimized my space, so that box will be, could go up till here, for example. Yeah, that box go up till here. So I have like bigger box. Yeah. So let me show you an example. So here is an example. This is extreme subplotting. It's extreme subplotting because see how many figures I'm showing here in one figure. And subplotting is very useful when for presenting your results, because these subplots, imagine if I'm doing this like each one of these in its own plot, that would be like 1, 2, 3, 4, 5, 6, 7, 8. That would be 16 figures. So I combined like 16 figures in one figure here. So that's what I did here. I combined like 16 figures in one figure, and it's basically telling like a consistent story. So you look at this figure, like when you read the manuscript, then you look at this figure, and then it basically tell you like is a complete story. So the complete story is here. I have a model here. This is like the calibration period, and this is the validation period, and you can read this as like part of this story is here. So this is the calibration period, and this is the validation period. And what I'm trying to do here, I'm trying to calibrate these models with different assumptions. So the first assumption, that's like standard least square. So this is during the calibration period, and this is during the validation period. This green lines, this is my model simulation. The blue dots, this is the observation data. And the red lines, this is the ensemble, my ensemble, like the credible interval, like the range of my prediction, because this model does not make a single prediction, it makes an ensemble of prediction, a group of predictions, yeah? And this group of predictions has, to account for uncertainty, yeah? Has like a credible interval. So this is what this like SLS model is doing during calibration period, and this is what it is doing during the validation period. And here are different metrics to measure how good this model prediction is. So for example, NSM Nash shuffle mean square. So you can see here the Nash shuffle mean square. You can read it here. The model prediction accuracy, reliability, and dispersion and overall predictive performance are measured by Nash shuffle mean efficiency. So you know that this guy would measure what? This would measure the prediction accuracy. Uh, predictive coverage matrix like the the predictive coverage matrix. This is measures the model like liability, and the sharpness matrix. This is measures the model dispersion. Model dispersion is like how wide like this credible interval is. So you see here is very wide, here is very small, for example. Yeah, and the overall and the relative modulus score that would measure the overall predictive performance, like the RMS. So you see, I'm explaining everything here. So if you want to know what does this mean, you will read it from here. Yeah. And then basically you can just like this figure basically tell you like a story. Like if you look at the overall, like let's just not look at the details, but let's just see which calibration method is better. Yeah, like the LS, the Gaussian one, or the non-Gaussian one, or the Gaussian one with weighted like residual, or the non-Gaussian one with weighted residual. So here, these are like these assumption, and here I repeated these four with accounting for autocorrelation. Yeah. So basically, this is same as this one, but accounting for autocorrelation. See, this one is same as this one, but accounting for autocorrelation. This is same as this one, but accounting for autocorrelation. This on the same as this one, but accounting for. So you see even how the figure is 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 analyzed like to make it like easy to read by even like see this is not a modeling course. You have no idea what I'm talking about, like what this result is about, but you can still follow up what I'm saying because the figure is organized. Yeah. You know, this is a calibration period. So for the calibration period, I calibrated my model for like 200, like about 8 months, and I validated my model for another 4 months. So this is like 4 months, and this is like 8 months. Yeah. So you can see like how like the calibration and validation period. And here, this is the variables that I'm predicting. Regardless of this, you see here, I'm putting the name of the variable, I'm putting the unit, and I have like, see my, all my y-axis are consistent because I just put it here. I didn't need to put it here because like the reader will understand that this one is the same as 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 this one, same as this one. Here, see my days here. The reader will understand that this one, like same as this one, same as this one, same as this one. So you see how I have an optimal use of my space. But anyway, so now if you want, like, let's say you don't know anything about this research and you just, based on the information you have, let's say you want to see which model performed better. So we can look at the uh, overall predictive performance. So we can look at the overall predictive performance, which is shown by the relative modulus score. So you see here the relative modulus score of this guy is 5, 5.9, 5.3, 5.9, 5.8, and 5.9. So obviously, like this guy and this guy performed better than this guy and this guy. Yeah. And when we account for autocorrelation, then they all didn't perform good because like you see 3.6, 2.6, 2.6. So what conclusion do we make from this? Yeah. So the conclusion we make from this is that like when you do the weighting and the non-Gaussian, that could give you or when you just do the non-Gaussian without like this weighting thing here, that will give you generally the best results. Yeah. So same here. Yeah. We see like this is 7, this is 6.5, this is 8, this is 5.2. So which are the best two? So my best two are like this one and this one, and my best two here are this one and this one. So now you see the story. Yeah. You see the story is obviously, so what does this story tell you? When you calibrate this model, you should use a non-Gaussian assumption about your residual. So that's a key message that you just got by just looking at this figure. Yeah, just looking at this figure and reading the figure caption, so you'll get this message. Yeah, and you don't even know what I'm talking about. You have no clue what this data is about, what this model is about, what is even efflux, but you just get this story. Now, when you read the manuscript and then you read the figure and you read the description that comes with this figure, then you will appreciate this, and you will say, okay, that's a very good figure. It tells me now, like this figure summarizes the whole results of this manuscript. Yeah, and it gives me like a guideline. So if I'm doing this, if I'm using these types of model and I want to calibrate this type of model, I should definitely use this non-Gaussian residual. I can also use this weighted, but I need to be careful. I should be very careful if I want to account for autocorrelation because that could complicate things. And that was one of the conclusion of this paper. Yeah, that do this. It's recommended to do this. You can also do this, but don't do this, or be careful when you do this autocorrelation thing. Yeah. So you see here. Uh, okay, now here is another example. Like, is this a publication quality figure? So this is also like I'm asking you, is this a publication quality figure? Yes, it is. Now you see here each figures are labeled like A, B, C, D, E, F, and like you can now read the figure caption. Monthly snapshot of sea surface heights about JUID. Yeah, so now you know that like what is you see here, this is sea surface height about JUID. In the figure legend, it clearly states this. I have consistent legend for all of them, so not each figure has its own legend. This is consistent among all figures, so now we can compare it. So like if it is blue color would be negative zero point 0.6 and point like red color would be zero point 0.4 or whatever. Yeah. About from, and then I specified the period from February to like, so that would be like February, March, April, May, June, for example. Yeah. For the high resolution, so this is for, oops, so I'm showing this here for the high resolution model and the normal resolution model. So this model has a high resolution 25 kilometer. This model has a low resolution of 100 kilometer. And what you can see here respectively. And then what you can see here, I could have added more. That's okay. That's also like optional. Like some people like to make a figure caption just to explain the figure. Some people will take this to a next step, not just add a figure caption to explain like the figure, but to explain also the significance of the figure or the main message of the figure. Which one to do? This is up to you. Yeah. Generally, I like to, in order not to, since I already explained the significance of the figure in the main body of the manuscript when I discuss the figure, I don't like to repeat it here to make like the manuscript like shorter. But some author, they would like to repeat it here in order to make this like a complete story, so that when you read this, you not only understand what this figure is about, but you learn the complete story. Actually, I got this comment from a manuscript that I was submitting just recently. The reviewer asked me, actually, so that was my style. So that's the style that I use. I don't make like, I just describe the figure so that I don't write the main message of the figure. But one reviewer once told me, also put the main message of the figure, the take home message of the figure, not just describe the figure so that the reader will understand it without knowing what is the main message of the figure. But this up to you. Let me show you an example of where a figure where I just put it and put like the main message of the figure with it. Let me show you an example for that. So you come here, where is this examples? You just find an example. Oh, we are doing in time. I think we're doing good in time. We still have some good amount of time. Let me show you an example here. So let's select like, I don't know. Let's select easy figure. Yeah, yeah. Let's look at this grade. Let's look at this figure. So you see this figure here, like, it's very legible. This is the project for 2024. This is the project for 2025. This is the exam score for 2024. This is the exam score for 2025. Student performance on project and exam score. Boxplot compares scores for AI assisted authentic project and the no AI final conceptual and basic skill exam scores across the cohorts, like the 2024, and I put the number of students here. There were 12 students, and 2025, and there were 13 students. Statistical annotation shows a p-value for an independent uh, samples t-test and the Levin test for an equal variance. So here, like, this is a p-value, and this is like, so basically if this is smaller than like a certain number, zero, like usually 0.005, this means that there is a significant difference. If it's not smaller than 0 0.05, then there's no significant difference. Same for the variance. You see here there is a significant difference between this one, but there's so basically, and let's just read like so you can look at this figure, try to see what it is. So this is the project score for the student, and this is the exam score for the student. So this is a project with AI. Both of them use AI in this example, like both of them didn't use AI in their final exam. Okay, the AI upgrade. So this is like the student here, they use like an old version of an AI. Here they use an advanced version of an AI. Yeah. So the AI upgrade led to satisfactory to statistically significant increase in project score. So you see this is statistically significant. You can see by here and you can see it visually, but no change, no significant change in exam score, because the exam score is similar, and you can see here by this number is larger than 0.05, so there's no significant change in exam score. Now I see, so here this is extra, like see this is extra things that I'm adding. So I'm just telling the reader the take home message of this figure. This suggests intervention like the upgraded AI improved applied performance without causing foundational knowledge to erode. So basically like when when the student uses better AI tool, they will able to do better project, but their final exam score or foundational knowledge where they didn't use AI didn't change. So they did the same in the final exam without using AI, but their authentic problem when they use like a real life project, their grade improved. Yeah. So that would be an example of not just like so here up till here, this will just help the reader to understand what this is. This addition is just telling the reader what is the significance of this figure. Which one to do? Like, do you want to do this one or you want also to add this one? This is up to you. Generally, I only do this one because I don't want the manuscript to be long. But since I noticed that like the readers of these educational journals, they also like these things, so I added here. Yeah. So it also could depend on like on the your industry, what's more common in your field. Yeah, what's more common in your field. Okay, but here this is just more common in my field. I just I can explain the figure, and then the significance of the figure I describe it in the main text. Yeah. Okay, but that's not the point here. The point here is that I'm showing you stories. What is the story? I didn't tell you the story here, but the story will be in the main text. The story is that like this high resolution model can simulate the loop current. So you see, this is the loop current here. This is the loop current here. See, now the loop current is growing, the loop current is growing, the loop current is further growing and start to dissociate, and then it start to leave the gulf. While the low resolution model for the same months, yeah, see, for the same months, they cannot simulate this. They cannot simulate this regional phenomena, yeah, because it's a high resolution and it cannot simulate this regional phenomena, so it cannot be used, for example, to manage red tide. But versus this one, it can, because it can simulate like these regional phenomena. Yeah. So now I tell my message. I'm not telling this message here. Again, I could tell this message in my figure caption. I could say like figure A to E, high resolution model can simulate the loop current versus low resolution model cannot simulate loop currents. That could be one additional statement here. But that's up to you if you want to keep this additional statement in the figure caption or in the on the on the on the what on the main text, yeah. But it needs to be there somewhere, yeah. Okay. How to make publication quality figure. You need data visualization and analysis software for sure. So you need like, so this figure, I need the software to produce it. Yeah. So for example, like this figure, I'll produce this use Python. So that's the software that I use. And if you want, we again, like this class, this is not about like how to produce this figure. We do this in another class. So environmental data science, that's basically where you will learn how to produce like this figure and this subplot and common legend, like how to produce a figure like this. That's where you learn in this course. But let's say you just produce this figure using like, what are tools that you can use to produce this figure? You can use like Excel. You can use online Excel. That's free. You can use MATLAB. You can use Octave. That's the free version of MATLAB. You can use Python. That's free. You can use TechPlot. TechPlot, that is for 3D figures. I mean, I can show you something. You can use ArcGIS. That's not free. So anything includes, these are the free one. Yeah. You can use QGIS. That's a free version of ArcGIS. You can use Penloopy, Penopoly, Penopoly, Penopoly. Okay. So Panopoly, this is from, I think, one of these ancient Greek story. Like, she was this lady who was weaving, like sitting in front of her home weaving and waiting for her husband to return back. I think that's Panopoly. I know it has. You can, it has a famous painting for her. But anyway, but Panopoly here is, it has nothing to do with this Greek mythology. Is this is a software for plotting like remote sensing and climate data. Okay, and okay. So you need to visualize the data using one of these softwares as I did here. But sometimes after you do this software, like this figure, I did it all with Python, yeah. But sometimes you don't like you don't have full control over this figure in Python or in MATLAB or in Excel or whatever, and you need to do further editing, further annotation. Like I need to put like an arrow here with some text. I mean, I can do this with Python, but it could be a lot of programming effort. It's not, but maybe I'm just for the sake of argument. Yeah, so you generally, what you would generally need, you will generally need an additional uh, editing software. Like if data visualization and analysis software is insufficient, you would need a graphical editor. So graphical editor, there are two types of graphical editor. Let me show you, like, it's good, like since we are talking about this, let me show you an example. Yeah. So let me show you an example. So you can come here. Let me show you an example. Like, so if you go to my website here and let's just look at this example. I will show you like one thing where I did and how I further edited it with a graphical software. So data analysis software and a graphical software. So let's see here. Let me show you an example. All these figure I actually use like, but let me show you a clear example. I did this for all this figure, but I will just show you like a very clear example. Here, this maybe that's a good example. So you see like this figure, see this figure, I created this figure, like see all these three figures, like see I created all these three figures using, like these are 3D figures. I created them using TechPlot. So TechPlot will only give me this figure. TechPlot will only give me this figure. TechPlot will only give me this figure. How do I have these like arrows and these text here? How do I have these arrows like and these text here? How do I have this A here? Like how do I combine like this three figure into one? Like, and I have A, B, C. So to do this, I use another graphics software. It's called like Adobe Illustrator. So what I did in Adobe Illustrator, like TechPlot will give me like this as a raster image, this as a raster image, and I will tell you in a minute what's a raster image. This as a raster image. Adobe Illustrator is not a raster, it's a vector editor, not a raster editor. And I'll tell you in a minute what's the difference between raster and vector. So what I did, I got this three figures, three different figures, like P, G, ping, for example, or GPG or whatever, or TIFF. We usually save this as a TIFF file. So three TIFF file. I will open an Adobe Illustrator project. I will copy and paste like these things, and then I will add these text. I will add an arrow here and then add the text here. I will add an arrow here and I will add the text here. And then I will add A, B, and C. Yeah, and then that's how I got like this one. I could also do this with PowerPoint. So I do this now, like since Adobe Illustrator, this is not a free software. Like if I want to do a figure like this now, I will do this with the PowerPoint, and I will show you this like in a minute. Yeah. But here, this like see, this is another example. Yeah. So TechPlot provided me with this figure. Yeah, and uh, MATLAB provided me with this figure. Yeah, and then or this doesn't look like MATLAB, this looks like ArcGIS. So ArcGIS provided me with this figure. I open Adobe Illustrator, I put this figure, and then I added, like, I change it, like, see here, see, I put like this label here, I put this label here, I put this label here, I put this text here, so I start to annotate like this figure and change this figure color. So I did this with another software. Okay. So this is an example. Like, so this example I showed you, like in this example I showed you, I produce my figures. So the data analysis software that I use in that case was like TechPlot and ArcGIS to produce like these figure. And then after I did this, if a data visualization analysis software is insufficient, like in that case, my data analysis software was sufficient. I did everything with Python. I didn't need to do any other software else. If this is insufficient, you need a graphics editors. Graphics editors that could be like raster editor, like this, like Photoshop, like Adobe Photoshop, or a free version of it, which would be GIMP, GIMP. That's a free version of this one. Or it could be a vector graphics editor. So a vector graphic editor, that's like Adobe Illustrator. So that's what I use for these figures that I just showed you. So for this figure I just showed you, that's what I did. Like, I prepared this figure using this tool and this tool. Yeah. You could also use Inkscape. Inkscape, that is a free version of Adobe Illustrator, or you can just simply use PowerPoint. And so what is a raster graphics editor and what is a vector graphics editor? Or more generally, like, what is a raster image and what is a vector image? So that's what I want to show you, but like, that's what I will show you next. But I just want to show you that, like, how to make this publication quality figures. The take home message here, that sometimes you don't only need like one software like Excel or TechPlot or ArcGIS or Python. Sometimes like you get like figures, different figure or the same figure from one software, and then you need a graphics editor, yeah, to do it. And I will show you like examples. Okay, so let's tell you what's the difference between like a raster and and uh, uh, and uh, and uh, and the vector image be, before we move on. Yeah. Oops. Let's before we move on. I'm trying to get my screen back. Anyway, doesn't matter. Before we move on. Okay, so a raster image, this is based on pixel. Yeah, so that's a raster file. So this is based on pixel. So the more the pixel are in my image, the higher resolution this uh, figure will be. So let's say at like, so the more pixel, and each pixel will have like one color. And that's why the more pixel I have, the higher the resolution of, and more vivid the image will be, because like each pixel, like, and depend, like, so this figure, so for example, if I zoomed in, like, you can see like the individual pixels. So that's the main difference between like a raster and like that's a raster. A vector is not based on pixel. Like, vector is just based on shapes. So if I zoomed in, it will not affect my resolution. See, when I zoom in, like, so let's say I just zoomed in here. So I just took this part here, and then I zoomed in. This tells you how many pixel are there in this part. So like in this part, I have some gray pixel here, I have some red pixel here, I have some gray pixel here, and that's basically, if there are more pixel in this part, this image in general will have a higher quality. Uh, and more, it will be more vivid and more vivid in color, because each pixel just represent one color. Yeah, see each pixel here, see this is a pixel, and each pixel just represent one color, each pixel just represent one color. Yeah, but if I zoomed in, you see the resolution is distorted. Yeah, and if I zoomed in further, the resolution will be further distorted, it will not be clear. Versus like a vector, these are shape. Like, so if I zoomed in, it will not affect my resolution. So let me show you an example. Like, so here, let's see here. Uh, See, this is an example of like, uh, oops. See, this is like a vector. So a vector would be shape. Yeah, so that would be vectors. That's like a shape. Yeah, so that's the shape. Yeah, like yeah, here, see, this is a shape. You can make it any way you like. Yeah, we can format it any way you like. Let's say any way you like. Yeah, if I zoomed in, I have the same resolution. The resolution is not affected. Yeah, versus if this was like because this is a vector. Yeah, vector is just a shape. Like let me show you another example of a vector. You see, that's a vector. Yeah, that's a shape. Yeah, if I zoomed in, that will not affect my thing. Versus let me show you an example of uh, of a raster image. So that's a raster image. That's not a vector. See, so the more I zoom in, that will see now. This the resolution is affected. Yeah, see, this is not as good resolution as when I won't zoom in. Yeah, because this is not a vector. Yeah, so that's the main difference between like a raster and a vector. Yeah, so vectors are fundamental difference. Raster graphics rely on assigning pixel or color value. So each pixel is a color value. So working on the grid. Yeah, so I have a grid here, and the more pixel I have, the higher resolution this image will be, and the bigger this file will be. Vector graphics are based on vector lines and curves. So these are just line and curves. And if I zoomed in, that will not resolution will get blurry if resize it, as you see here, will not be blurry with resizing. Efficiency. This is uh, simplest shapes here are pixels. So the simplest shape here, like what is this image composed of? This image composed of like all these combination of pixels. So the simplest shape here is pixel. The simplest shape here is outline or simple shape. So the simplest shape here is this outline, like these lines or shapes that I put in. Yeah. The when what are the file extension or file type for like raster images? This could be pinch, this could be jpeg, this could be tiff, and this could be gif. Like um, this is like animated figures. Yeah. What are the extension for these guys? That could be EPS, SV. Like this is I don't remember like what is this stand for. Like SV, I think this is vector something. V here stands for vector. SVG, PDF, and AI. So I think AI that's Adobe Illustrator. Yeah. PDF, and this is just another. So if you want to have like to save your image as a, you can create an image as a vector shape and save it as a vector, or you can save it as a raster. Yeah. But if you save it as a raster, you will not be able to. Let me show you an example. Like, so let's say here. Yeah. Now, like, see, let's say here, let's say this is an image. Yeah. I could save it. Like, see here, if I could like say copy. Now I could paste it as an image. So now if I paste it here and as an image, now this is a raster. This is no longer vector. So you see, I cannot edit it anymore. And now this is a raster, and then now this is a raster image. Yeah. Here, this is a vector one because you can see here, I can play with it. I can edit this shape while this is now a raster. Okay. So let's go back here. Okay. And now editors like Adobe Photoshop has a very famous editor for raster image. Like you can create an image that looks like this with an Adobe Photoshop, Microsoft Paint, and GMIP. So this one is free. For vector editor like uh, Adobe Illustrator, PowerPoint shapes, I just showed you this one. Inkscape, that's like a free version of Adobe Illustrator, and TechPlot, I just show you like this one. So this is not free. Yeah. Okay. How to use like a graphic editors, the use of graphics editors. Like if you want to use like one of these graphic editors, remember there are two software. One software for generating your original figure, like that could be Python, that could be Excel, that could be whatever. That could be also one of these if that's what you're doing, yeah. But generally not, but it could be, yeah. But if you want to use a graphical editors to improve your figure, like why would we need a graphical editor? So not enough autonomy over the figure in data visualization and analysis software. Just as I showed you with TechPlot, I don't have enough autonomy in TechPlot to have like these three figures in one and to add these text here and to add this here. So that's why I don't have in the visualization and analysis software in TechPlot in that case. Or maybe if I'm using this with Python, like for example, like I'm doing this with Python, yeah, and I don't have like I'm not a good programmer. I don't know how to put like this A, B, C, D, E, F in Python, for example. So I want to take this figure and put this A, B, C, D, F in another software. Yeah, that could be Excel. So I could just copy and paste this on not Excel, on PowerPoint, and then add this as a text in PowerPoint. You understand what I mean? Let me just show you how to do this very quickly in let me just do show you how to do this in like so in PowerPoint. So so in PowerPoint, if I want to do this, I will just come here and then let's say like it already has this one, but let's say I want to add something else, yeah, like text, like insert text, yeah, here. Like I will just repeat it, A, for example, yeah. So I can just like come here and put A, yeah, and then Control C, oops, Control C, Control V, I come here and put like B. See? And then I can do the same like C. And then after this, I could just come here and like click all and then save as a picture. And then I could select like how I want to save this. So I want to save this as like PEG, for example, or whatever. Yeah. Or so I want to save this, then I can now save it as a figure. Yeah. And see, if I want to do more annotation, I could just come here and put like an arrow here and describe something, and then again you save it. Yeah. So that's how you can do this with PowerPoint. But in that case, I did everything in MATLAB, not MATLAB, in Python. Okay, so now if so too much programming effort, like you don't know how to do this with programming, like how to add this with programming, so you get it in another software. Yeah. So what do you need? Like if you need a graphics editor, it is easy to work. Like if you need a graphics editor, it is easy to work with them together. Yeah. Edit a raster image in a vector editor and edit a vector image in a raster editor. So you can do both. Like so here what I did, I got like what is this image? So this image is obviously a raster image, yeah? This is not a vector image. So I got this raster image, yeah? And based on what I want to do, I want to add like this A and B and like C and whatever. So I use this using a vector software, which is PowerPoint, yeah? PowerPoint, by the way, is also a raster software. It's a raster editor because it has like I don't have it here. It has draw. You can also draw. So if you start drawing here now, this is not vectors. This is raster. Yeah, like you see here, this is not vector anymore. Now this is raster. Yeah, so this is like a raster image. This is not a vector anymore. This is just raster. So actually, PowerPoint, I like to use it very much because I have access to it for free. Not everyone might have access to it for free, but I do, and uh, I can use it as a vector editor, and like so now here, and I can use it as a raster editor also. So vector editor by inserting shape, raster editor by drawing things. Yeah, but of course it's not as powerful as Adobe Photoshop. Yeah. So here let's just do this as an example. Like I think we have about like 10 minutes for this. So let's just do this as a quick example. Like, so this is a figure that I generated with Python, but I don't like this figure. Why I don't like this figure? I think this font size is small. I don't like this two-seater. I would like to start like this legend here with uh, with a capital letter, not small letter, because properly when Python took this, he took from the header of my tables, of my spreadsheet table, and then just plotted whatever there is a header. I want to make this more beautiful. See, highway and city, I like to write highway, I like to write city, and I like to uh, make it like bigger font also. So how could I do this? So how could I fix these problems? Yeah. So again, I created this problem using Python matplotlib. So this is Python matplotlib. You can learn here, for example, like of some of the. Oops. I mean, you can just see here like an example like of how you can some figures that you can do with. I think the figure is not now. Like, probably it has so much traffic on it, so it's down. But anyway, you can just see here like example of how to produce this figure. Now, so I want to make this changes. So how could I make this changes? So one way to make this changes, I have like several ways to make this a change. One way I can just like like let's say I have this figure, yeah. So one way, like if very easy, like if you want easy way, but it's not the best way to do it, I can just like snip it, like you see here, or just open my file in PowerPoint. I will just for now I will just snip it, but I can also open my file in PowerPoint. That's like the files that you save, you open it in PowerPoint. So that's just one way of doing it. So like here, the files that I saved, yeah, I will just open it in PowerPoint. Yeah. Uh, and then that will take a lot of effort to do it this way. And then I will hide like these guys, I will hide this guy, and then I start typing them myself. So I can just come here, shape. That's not the best way to do it, yeah? So I can just come here, hide this guy, like shape fill, for example, I make it white, shape outline, I make it white. See, now I hide this guy. I can come here and like also like hide this guy here, yeah? And then start typing it myself. So I say like insert, then insert text, like text here. I don't remember what this text is, but let's just check what this text is. So that would be like my miles per gallon mpg in 2018. Yeah. So now, so where is my thing? Here we go. So I hide it again. Yeah. And then I bring this here. So you see now, miles per gallon. And then now I want to make this font like larger. So you see now, that looks better. Yeah. And I can do the same. I can hide this guy here and rewrite it again, or just get like these colors. Like let's say how I want to do this. Like if I want to do this, I can redo it. Yeah. I can just get like this orange color. So how I get like this exact orange color. So you come here like shape fill, you select this one. I want this exact color. Shape outline. I don't want to have any outlines. And I can, let's just hide this guy here like shape. I want to hide this guy here. Shape fill like white. Shape outline white. And now I can put my legend anyway. I don't need necessarily to put it here. So I can put my legend here and I can say this one, like, this is what, like, this is, and then I'm just showing you, like, so that would be like, okay, city, yeah. So that would be like city, yeah. And then I do another one for whatever, like highway. So now that's one way to do this, yeah. So that's like one way to do this. So there are three alternative solutions. Uh, uh, do require the programming effort. So the first thing is just do it with Python. Yeah, because with Python, if you are a good programmer, you can just like tell Python to do whatever you want to do. Tell him like, for this legend, use this. For this one, use this font size. For this one, increase the font size. For this legend here, use highway instead of this. So just do the programming efforts. That's the easiest way to do it, actually. It's just like you do the programming effort, especially now with AI. AI can do all this for you, can all do all this programming for you. So if you just give this code here, so so this is the code that I use to do this figure. Yeah. So this is the code that I use to do this figure here. Yeah. And but uh, let's, yeah, okay. So those are required programming effort. Another way, create a vector figure and manually edit it using Inkscape, which is a vector image editor. I can save, when I do this, I could save this, like I could create like this figure with Python and save it as a vector image. Then I go to like a vector software like Inkscape and then edit it there. Yeah. So if this is a vector image, this means that this will be like a text that I can edit. So I can change this text. I can make this capital. Yeah. I can change the vector font size because this is vector. Remember, vector means that this will be separate. This will be separate. This will be separate. So I can just come here. That would be text, and I make this capital. I will come here. I will change the font size. I will come here. I will change the font size, font color. I will come here. That would be text. Yeah. And then I can change it because it's a vector. So I can create a vector figure manually and edit it with Inkscape. Create a raster figure without axis, text, and legend, and manually add them. So that's what I did here. So I just did here the third solution. So when I created my figure with Python, let's go here to my figure. So like, see, this is my figure. I'm opening it with Binder. See now, this is the importance of being fair, extra fair, like, because like I can now like play with my figure and do this demonstration. Yeah. But I mean, sometimes it might not work, sometimes it work because this, see, they said like donate to Binder, so their site could have high traffic. But anyway, so you see, you don't even need to have Python on your computer installed. You can just open this here, and you see here, this is the figures that I did. So you see what I did here. You need to like, let's run this. Panda is not installed, so you want to install it first. But anyway, this is not important. Control C. Like, if I want to run this, I have to first install Panda and then install this one. But see here, I created this figure, and then once I have this figure, I can just add the text by myself. Yeah. So this is what I did. Like, I created like a raster figure, and then I got this raster figure, and I'm editing with a graphical editor. In that case, I just edited with PowerPoint. Yeah, here. See, I just edited with PowerPoint. Like, let me show you. So I just get this figure here. Yeah, and I just edit this with PowerPoint. See, I just added this text here. I added this here. I added this here. I added this here. So that's like how you do. So there are three solutions. Yeah. So there are three solutions for this. Like, because I need to end this video now. The first solution is that you do the extra programming effort. The second solution is that you do like a raster image and edit it with any software you like. The third solution is that you save it as a vector image and edit it with the vector software. So I think that's all for this lesson, and we'll see you in the next lesson where we're talking about like vector, about other things. Okay, about graphical, abstract, and conceptual diagram. Okay, so see you in the next video.